What do you say we start with a bit of an introduction from each of us for those who don't know us? So Jakub, the floor is yours.
Yeah, so I'm an AI dinosaur. I'm really looking forward to next week, and I'm the founder of Zeta Alpha and omnivore of AI knowledge.
Cool, thank you.
To our show.
Marzi?
Hi, everyone. Good afternoon from Amsterdam. I'm Marzi. I had my PhD in machine translation from University of Amsterdam, and I do research at Zeta Alpha. And it's really exciting to end the year on a high note with NeurIPS papers. And also, I think these would shape a lot of things that will happen next year. So I look forward to discuss these papers with you guys.
Thank you. And finally, my name is Sergi, and I'm the AI community manager at Zeta Alpha. So I try to read and check out some papers and find what's interesting and write about it. So I write this blog monthly that we're going to talk about today. And yeah, like Marty said, I'm quite excited that we end the year on this high note with NeurIPS papers that are always a bit, I feel like, quite more polished and nicer to read than some of the other archive stuff that we are used to checking out the rest of the year. That said, this meeting is for the people who are just getting in. This webinar is being recorded, so we'll share that later with all the attendees. But yeah, you should know that. And secondly, please drop comments in the chat, because you cannot talk, but you can just give a suggestion, comments, and we can talk about that later on. Yeah, that said, what brings us here? NeurIPS 2021. Jakub, you have a few words.
Normally, we at this point in our webinar, we gloss over all of the AI news that's been going on. There's actually been a bunch of it, but this month NeurIPS is coming up, and we're just going to focus 100% on it. Except, well, maybe everybody's getting ridiculous investments and everything. And well, you can read it on TechCrunch, for example. But I did want to notice this thing that actually yesterday, Timnit Gebru announced the formation of her own sort of ethics AI research institute, DAIR. And interestingly, at NeurIPS, you can see her live in action. So on Monday, she's presenting a tutorial on exactly her topic. So I'm excited to watch that. What do you think? Are you guys going to see it? Is there too much attention for ethics in NeurIPS?
No, I would say definitely not. I also look forward to next week, and it's like a good start of the week.
All right, so for those of us who haven't used or heard about Zeta Alpha before, just a very short detour on what we do. So we're Zeta Alpha. We're harnessing AI to help AI people find better solutions to AI. So that's pretty much very meta. So another way to say it, it's a smarter way to discover and organize knowledge for AI and data science teams. And our platform to do that is this. And of course, the NeurIPS papers are in. We have more than 2,300 NeurIPS papers indexed and fully neurally and semantically searchable in our platform. So you can start your discovery using your favorite topics, snippets of text, etc. Find papers using these transformer-powered neural search. Find similar papers, browse from there, explore these visualizations. You're going to see some of these visualizations later on, which are really useful to kind of map out what's in thousands of papers in a semantic way. And we also cover code and social media. So you can find, for example, what's trending on Twitter or on GitHub. And then the goal of the platform is really to organize work that you discover in topics, in collections that we call tags. And these tags start to work for you like an automated research assistant. And basically, once you have tagged papers, you receive, when there's something coming out which is highly relevant for you, on a need-to-know basis, recommendations tailored to you. So we don't just dump recommendations to you, but we filter them to your personal interests. All of this lives in a kind of team setting, so you can not only work for yourself, but you can work within your entire team and share and reuse knowledge that you have discovered. So that's the platform. For those of you who have already used the platform, we have a couple of exciting new features that I just want to briefly mention before we dive into NeurIPS. And one is that we allow you to import your private documents. So if you have any sort of document locally, you can upload it and have it fully neurally searchable. And you can also upload existing document collections from like a reference manager. If you have Zotero or Mendeley or EndNote or one of these, you can upload your whole collection and it will start working like a research assistant for you by making recommendations and filtering new stuff. So that's very cool. If you have Zotero or Mendeley or one of those other things, drop a note in the chat. We'd like to know what you're currently using. And something which is not released yet, we're working on that. I think will be released today, right? I hope.
I think that's a plan. Hopefully,
yeah. So we have a release planned for later today. And really connecting with knowledge is also about connecting with people. So a new feature that we're just about to release is that you're able to basically not only follow papers and discover papers, but also discover people and follow their future publications. And you can also follow people in your team, what kind of knowledge they're sharing, and what they're updating. So for example, Marzi, right, you're doing a reading list in our tool. So
yes, I'm keeping track of interesting papers and a list of what we want to have in our reading groups, and it's really exciting to be able to share it with people.
So now it will be even a lot less obscure when you're doing updates. Everybody will be able to see it in your team.
Yeah, we are in a way like solving our own problems because we are our own users. So it's also that really nice.
Yeah. I have to say I was pretty happy that this year we had these new semantic maps for NeurIPS that we didn't have last year, because it is quite useful when you start when you want to map out like a very big space of documents that you have no idea how to start. So yeah, that's it. I think I can pick it up from here. Let's dive into what's interesting from this month. So if you haven't checked out, you can read the blog post on our website. And you know, about a week and a couple of weeks ago, I think Jakub and I talked a lot about how overwhelming this NeurIPS was, because it seemed like there was so many interesting things, but there's more than 2,000 papers. So I mean, as you can imagine, we could not read all of these 2,000 papers, because that would be a full-time job for years. But we had this feeling of being overwhelmed. So we thought that we should at least give a seed of where can people start, and to like to give it like a seed of where you can start to you know, dive into this collection of more than 2,000 papers. So we try to collect
the rough guide, right? The rough guide to NeurIPS.
Yeah, exactly. But I like to think of it as like a kind of a few entry points through which you can start to dive in deeper into different topics, and I tried to make a selection that was a bit varied in the topics that it talks about. So yeah. So that said, what else would you like to highlight about NeurIPS?
It's huge. 2,300.
How many attendees are? And
it was
attendees,
just overwhelming, right? I was overwhelmed when I started digging into it. How about you?
I was absolutely overwhelmed as well. I'm still a little bit, I have to say. Marzi?
Yeah, I mean, in a way we are getting also used to these conferences growing every year, so it's not a surprise that there are a lot of papers, but you do get a feeling that there's always something that you are missing because you didn't get a chance to find it or check it out.
Yeah, I do feel it's easier if you have a very specific, like a very specific interest in mind that you want to dive into. You have a very specific niche. But if you're more in the side of, okay, I just want to get a good sense of how the field is moving, that gets pretty hard to recognize.
Yeah, and so it's more than a week, right? So it's going to start on Monday with tutorials, and then the main conference is on Tuesday till Friday, and then the workshops continue until next week, Tuesday. So it's like all of December is just gone, glued to the screen. And I found out in one of the papers, it actually had like a little line. It was supposed to be in Sydney, so we could all have been in Australia right now. Online only.
I know the schedule is a bit weird. Is it based on Sydney then? I mean, weird in the sense that
I think this is my schedule, and it's based actually on Amsterdam time. Not 100% sure.
Okay. No, but it's 2 a.m.
The NeurIPS site is live, and you can set your time zone, and we'll change all the times for you. Yeah, I think, Marty, you mentioned this volume. So I borrowed this little graph here from Sergey Ivanov. I think he's from Criteo. He graphed it out over the years. So it's really been growing a lot. I think it's now more than double the number of papers from 3 years ago.
Yeah, indeed. One of the things though that I find interesting is this the submissions rate, right? Because last month we did talk about how the growth in archive papers seemed to have slowed down in 2021, and we were wondering about what it was. And it seems like the year-over-year growth on the accepted papers is still increasing, but the submissions rate did drop a little bit.
Well, some of the papers are really long. I read a paper with 29 pages. I don't know if that's a proper NeurIPS format, but
yeah.
All right.
Yeah,
so
I can think of, like, in a year or two, there probably will be studies about the change in paper submissions that we see in this year and why it's happening.
Yeah, it's been an interesting year, to say the least. And I hope next year is going to be different, for sure. But yeah, things continue to move forward in AI. And so one of the ways that you can kind of start to navigate this program, I mean, it's a lot of papers, 2,300. So their best paper awards were announced a couple of days ago. And I don't know what you guys think, but I found them very theory heavy. I mean, there's a lot of different topics from self-driving cars to drug discovery, NLP, computer vision. But most of the best paper awards really went to theory heavy papers.
Yeah, it does seem like it. I agree that for my taste, it was a little bit like that as well. But after looking at all of the conference papers, there is a very strong, a very big number of papers that focus on the theoretical aspects of things. So
two papers that I kind of wanna single out is this mauve. So people working in NLP know there's like bleu and rouge, and well, there's a new color now, mauve. I'm not sure what color it actually is. I think it might be close to the color I put in the background there, but it's a very interesting paper actually on for like all these large language models. You are measuring the quality of generated text, right? And this mauve is a new measure to kind of measure the quality of something like GPT-3, how good that text is, which doesn't exist yet. So you cannot compare it to something, but it's an interesting approach. And I think it will have a lot of impact.
Yeah, I think Marty, you also mentioned to me some paper that was on some new scoring system, a new scoring metric, right, for NLP systems.
Yeah, so I think the whole area of evaluating tasks that are based on generating text is not really is something that is still going on, and like figuring out a good way of doing that. And the classical ways of comparing with a reference text to see how different it is, like Jakub mentioned the blue and rouge are classics, but when you see at NeurIPS, there are two papers. So there's one this small, and then another, which is called the BART score.
By Graham, the BART score.
Yeah,
BART score, yeah.
By CMU people, Graham Newby and his colleagues, that they also look at how to evaluate automatically rather than comparing with a human-generated text, basically. And yeah, I think that's a good direction. That's like all of these new ways of evaluation would help the field to actually analyze how powerful these models are, all of these large language models and fancy new things, and going forward and progress from there.
And I thought it was interesting. They have now a special Best Paper Award category for data sets and benchmarks. One is a little bit more like the sociology of using data sets, but the other one was a Atom 3D, tasks on molecules in 3 dimensions. It's really kind of about this drug discovery and this whole, like machine learning on molecules and proteins, and that's getting really huge. I know that, for example, Microsoft is opening a lab in Amsterdam on that, and lots of people are getting it. We'll be covering some more papers on that.
Max Welling's going to be spearheading that.
Yeah. That's everything to do, of course, with a large amount of attention also to graph neural networks, right?
Yeah.
Graph neural networks and molecules, they fit together really nicely.
Equivariances and all that.
So what did you guys think about the keynotes? Did you check out some of the keynote speakers?
I glossed over them.
Haven't yet, I have to admit.
I glossed over them. It seemed none seemed like an outlier or anything.
There's an interesting talk from a guy from the CEO of Duolingo, the language learning app, how they use AI, and Daniel Kahneman. I'm really looking forward. Always a kind of great thinker and speaker. And there's a great talk also about swarm intelligence, like ant colony optimization for solving hard computational problems. Is interesting, and a lot of attention for like diversity and gender and like all the stuff that, let's say, modern left-wing academia is struggling with. Also very present in the keynotes. I don't know. It's a technical conference, but some of it is good.
We'll see how that goes. Yeah.
So how do you discover something in 2,300 papers? Well, the Best Paper Awards are one way in. Authors that you know are, of course, another way in. So we, Sergio already said it, right? Like this sort of semantic clustering in Zeta Alpha. So what we do here is basically do similarity calculation on the basis of the content of the paper. So this is not a citation graph, but really a semantic landscape. And then you can, for example, look at the citation indexes of the authors, and the size of the nodes reflects the H index, like the authority of a certain author. So here you can find the different clusters, like reinforcement learning, graph neural networks, computer vision, privacy sensitive learning, all these different machine learning theory. You see all these different clusters, but the size of the nodes, you can like pick out the papers from the well-known researchers. If you're starstruck and you want to know what Joshua Benjo is doing, or some of the other famous guys, this is the way to discover. This is another way. I think Sergi will talk a little bit more about that. But actually, a lot of these papers are already on archive. And if you deduplicate the NeurIPS publication with the archive one, some of them have actually already had a lot of impact, and they are already cited in other papers, even like before the conference starts. And for example, here you see the MLP mixer and a few others. So that's also something that you can kind of discover in this way with this type of visualization. So these papers are already famous. They have more than 10 citations.
Yeah, I think that it is quite interesting, this effect, because it happens to us that sometimes it's hard to say what are we going to highlight, like stuff that we find is interesting, but a lot of that overlaps with stuff that we have already talked about. So that's kind of an interesting thing.
We had quite a few of these papers in our webinar already, right?
Yeah, absolutely. Like a lot of these we have already talked about. I just wanted to say that a big impression that I've had from going through the program is that there's a lot of exciting papers on the computer vision side after a couple of years, maybe where like there was so much like NLP kind of focus hype, or I don't know, like GPT-3 was one of the highlights from last year, for instance.
Yeah, and
this year you see a lot
multimodal things also, right? Like the grounded language models and
absolutely. I definitely think that that's
vision,
one of the
speech and language and all that.
Yeah, I absolutely think that's one of the directions that the like the big language model kind of trend is gonna move towards. So
yeah, so even if you have already read these papers, I think NeurIPS is a great way to actually see the presentations and interact with the authors and kind of always get a little bit more a live take on what some of these papers are about. So check these out. They're also in Sergi's blog. That's on our website. So you want the list.
All right. I think that we are starting to dive into the specific papers now.
The essential guide, the 10 papers that you shouldn't miss, according to us. Oh,
yeah, according to us. Right? If you go to the first one. So the first one we're highlighting is in this same branch of paper that we just mentioned about, applying machine learning to biology stuff and then organic chemistry type of things. And I think this is a good example of that kind of the family of papers. What do you have to say about this, Jakub?
It's a super good paper. First of all, it's a great read, and it builds. It's not the very first 3D model of molecule generation. It actually builds on this this work right here from last year by people from the University of Pittsburgh. But they did a kind of more old-fashioned approach with convolutional neural networks and kind of strange way of generating molecules with different networks, with a variational autoencoder and a GAN and a generating network and all that. So these guys, it's a combination of Chinese company, Peking University, and University of Illinois. They actually have a completely new method, which is based on graph neural networks. And they use graph neural networks to kind of autoregressively generate like sequences of new proposals. And it's a bit like you have this protein binding site, which has a particular form, right? And then they just like start to generate molecules by inserting atoms in three-dimensional positions in that space. And it's really fascinating. And it works really well. So they get like a lot higher scores than any previous work.
Yeah, and, so I think that the main like the difference between the previous work is that they generate conditional on these binding sites of proteins, right? So you can do some fancy
but on the three-dimensional
type
structure of the binding site. So they really like model out the 3D structure of this binding site, and then like basically use Monte Carlo sampling to generate new atoms that until the whole binding site is full. And here you see some of the structures in the lower right-hand corner that they generate, and they have this very nice kind of contrastive sampling methods to train the thing. So really, really worth reading.
Yeah, and I mean, this, like I said before, this is really just one example of a lot of papers on this family, right? I think that the next slide you have another example?
One last thing I wanted to mention. So I checked, and the best paper award is this Atom 3D, which is about the same thing. It's a data set about this task, but they didn't use it. So you also see a lot of disconnects, even in such a small subfield. So the next one, well, there's a lot of papers. So I found through our Find Similar that actually Joshua Benjo is Emmanuel Benjo is a family. It's not his brother. I think it's Sami, right?
Sami is his brother, but I don't know. Never
Maybe
heard of
him. So anyway, they're also working on this like generating molecule candidates for pharma. So it's a very hot topic, and yeah. So this a lot of that with graph neural networks, but I don't know anything about graph neural. I think there are a couple hundred papers on graph neural networks. So I asked I asked Thomas Kipp to like give me some highlights, and he was so kind to suggest a few papers. So this is one of them: Partition and Code.
Yeah, I really like this one. I'm quite a fan of this whole idea of looking at things through the lens of compression. And at least this paper does a really good job, right, of doing from the ground, like explaining how you would go about compressing graphs. What do you think, Jakub?
Your master's thesis was about compression, if I recall correctly.
Yeah, yeah, it was.
Yeah, so the idea here is to compress like really large graphs. Interestingly, Michael Bronstein, the last author, is from is at London and University and at Twitter. So I know one sort of large graph that you could compress, the whole social network of Twitter, then you can put it on your phone, have a local copy. No, but they say that it's the first paper which uses graph neural networks to do really kind of graph invariant compression. So what they do is they basically you can see this in this picture here. They kind of take the graph and the connectivity, and previous approaches to compressing graphs have really been kind of serializing the graph to a string and then doing classical compression. But it doesn't really work very well because when you kind of change, the graph doesn't have an inherent string order. So when you change the serialization, you get a completely different compression. So what they do is they generate this dictionary of, they cut the graph up in small partitions and then generate these like little atoms or mini molecules in the graph. And they build a dictionary of them and then use classical information theory to encode them. But the really nice thing about this paper is that they use a kind of minimum description length loss to optimize all of these steps together. So that's the beauty of it. And they get very large compression gains.
So one of the open questions to me is still to what degree this is gonna be used, because you see with a lot of these technologies that the ease of use or like the simplicity of the method is really important for people to actually use it rather than the performance. So I'm really looking forward to see if like what other people do with this, if it gets picked up and gets used in practical compression algorithms.
Yeah, this is prototype-ish. This is super creative, nice written paper with very like exploring very new ideas, but it's like breaking new ground, I think. And I think it's gonna be pretty impactful. So just wanted to shout out thanks to Thomas Kipp for this suggestion. And here's a few other tips from him: Simona, VQGNN, and GemNet. And GemNet is also about drug discovery. So if you want to get some of the best graph neural network papers, check these out: Simona, VQGNN, and GemNet.
Cool. So yeah, next up, I wanted to highlight this one, this paper, The Emergence of Objectness for Learning Zero-Shot Segmentation from Videos, because I do think it's a very interesting also family of papers that you can see in NeurIPS, which is the leveraging self-supervision in vision. I think it's been growing really a lot in the last couple of years, especially like when things like SimClear were released almost 2 years ago, and now everything is about self-supervised, leveraging self-supervised signals. And this paper, they do this very nice thing of using video and doing a clever way of mixing like flow data and a reconstruction loss to learn zero-shot segmentation that I think is quite interesting.
Is it 3D actually? Do they like segment out 3D models of objects, or just?
No, it's only a 2D map
right.
for segmenting.
It's cool. Yeah, I've not seen that before.
So I don't think we have a lot of time, so I would like to go to also the next one. So this is also one example that I had to put it because I think it's really interesting, but we already talked about it a couple of months ago, which is this idea.
Déjà vu.
Yeah. Which is the idea of using pre-trained language models and sort of using that frozen model that has never seen images, and then on top of that train a vision encoder, and then use it in a prompting mechanism to solve some specific task. And it is interesting to sort of peek into what these pre-trained language models, what sort of knowledge do they keep from their pre-training in language, and how that can be leveraged to solve other tasks. But yeah, I think that's fascinating. I'm really looking forward to other works on multimodal prompting and all of this, because I think in the last year we've seen a lot of developments on this.
I saw a Hugging Face demo on Twitter today, which it was prompted by a movie poster, and then it would write actually the synopsis for the movie. I don't know if it's using this model.
Sounds really interesting. Yeah, but it does seem in the same kind of family. Yeah. Okay. Yeah. So next up, we go to the to the domain that we are a bit more familiar with, especially neural search. So one of the things that keeps people up at night in neural search is how you do contrastive learning, right? And how you have good negative samples and all of these things. So I think that this is a good paper in that sort of area. I think Marcy checked it out. So what is your opinion on this paper? Can you give us a quick summary of it?
Yeah, sure. So yeah, like you said, neural retrieval, it's a hot topic now. And so a lot of these models are based on training a bi-encoder or a two-tower model. And usually for these, you need a pair of query and documents to train, and often query and positive documents for positive signals, and some negative samples in order to rank the positive example higher than the negative ones, right? And there's a lot of different ways of how to pick these negative samples. So the most common one is to use the in-batch negative sampling. So basically use everything else in your mini batch of training as negative. And this particular work actually looks into one of the problems of these common ways of picking negative samples, and that is that over time when you train, they become less and less informative. So the value of your gradient would be really low towards the end. So basically the model is not learning anything from these negative samples because they are random and they're not hard enough. And another hypothesis is that the more negative samples you have, the better. But of course, there's a computational, like memory and time limitations that you cannot increase that. So basically addressing these two problems, this work proposes a method to basically cache these negative samples and sample from them. So they use the Gumpel max sampling to basically pick these cached embeddings in each iteration. And once they try to increase the size, so in one table, you see that the number of negatives, they can go as high as 2 million, which is like really a lot. But once you increase the size, then the sampling itself can become again inefficient. So that's why they introduced the streaming variant of sampling that they name, which I think is a really nice addition to what they already do.
But you don't have all the 2 million cached negatives in GPU memory, do you?
No. So it's a rotation of basically updating the negative samples every couple of steps. So in this scenario, the next column is like how many updates per step you would do, and
Right.
rotate the sample.
So it's like a classical kind of computer science cache where you hit them or miss them, and then you update the mini batch.
I guess the obvious question here is, Marzi, do you see yourself applying these techniques to our own research in the near future, or are you not that impressed?
Yeah, I think because we also have actually been looking into different ways of doing negative sampling, and this is a good way of increasing the size and the diversity of samples that the models see during training without losing on like the time for training, and also like requiring huge amounts of TPUs. So yeah, I think this would be a one good candidate to actually implement and see how it works.
Is the code available? Is it on GitHub?
Not as far as I could see, but that's a good question for the authors in the conference.
All right, let's ask them.
Yeah, actually.
Some of the code is going online like right before the conference. It was probably required by the reviewers.
Yeah. So I just want to like mention one example that they also put in the paper, that to give you an idea of like how memory intensive this sampling would be if you are training a BERT-based model, and you want to have like a one negative sample in your batch, you would need 600 megabytes of memory. So that's just like for one negative sample. So like being able to actually scale that to a large amount, it would be a really powerful approach.
Cool. More neural retrieval? Or is this?
I don't think the next paper is on neural retrieval. I don't know if Mark, you have any. Yeah, it's on this whole multimodal thing. So this is a good example of one of these papers that does a pretty large scale training of a large language model. Well, not language model, but a large transformer, and mixes the modality of video, audio, and text, and does some clever self-supervised training like noise contrastive estimation. And they basically like do some positive pairing of bits of video and bits of audio and text, and kind of the model has to learn to sort of know that those go together and others go separately. And with basically with this pre-training, they get this large model that can perform a lot of tasks in these three domains. And I feel like that's a really interesting direction because I mean, as humans are kind of always getting information in different ways and combining everything. And we've seen a lot of machine learning that specifies, specializes in each domain separately. But I think it's interesting to see what can be done when all of these things.
There was this discussion on Twitter yesterday. Thomas Wolf of Hugging Face, he was saying like a lot of these multimodal models. Seems nice for representation learning, right? Like more different modalities, more constraints, better representation. But he pointed out like none of these models actually beat plain text models on any of the sort of perplexity or kind of language only benchmark. Is that also the case here?
I don't remember the specific numbers, but I would say that I wouldn't be too worried about that because, like the language only, sort of text only language models have existed for quite a while now, and they have been like optimized to, to hell basically. So, like when BERT was released, subsequently, there were a lot of papers kind of released saying like, hey, we trained BERT and it works actually way better than the original authors. And then I feel like there's a lot of kind of over optimization that these kind of multimodal models can probably
we haven't
get
seen the last
to.
Of that yet, right?
Yeah. So I feel like we should give them some time to get the details just right for them to be.
My impression to add to what Sergi said is that I don't see multimodal learning as being able to do everything that each of those modalities are doing, and on top of that something else, but rather doing something interesting that them in separation they wouldn't be able to do. So if there is like you are able to learn something that having only a model trained on text or audio or what video cannot do. That's the interesting part.
And for example, you worked on machine translation, right? So can you see like machine translation model not making a specific mistake because it has the audio available of a, let's say, of a Chinese or a speaker, for example?
I don't know about the audio, but just like the image, yeah. So that's something that there was already
right. The image would disambiguate the word, for example, right?
Yeah. So the image like an image has says 100 words, right? It has a lot more information that the sentence does not. And there has been some work on, I haven't checked recently, but some work on like image and caption of the image translation. So yeah, definitely it adds a lot to it.
Very nice. All right.
Yeah. So next one is in the reinforcement learning category, right? There's
it's a huge category. It's a huge category.
Heavyweight authors. I think it's a really nice.
Maybe before moving here, there's a question in the chat for the previous paper.
Let's cover that.
Yes. So Henning asked, which data sets did they train on? Equal representation of video, audio, and text, or different ratios?
Good question. Let me look it up.
We'll come back to you in a second.
They mentioned, yeah, pre-training data
Zeta
sets.
Alpha. We have a question answering module.
One point what I get from here is from it contains 1.2 million videos, each providing multiple clips with audio and narration scripts, resulting in 136 million video, audio, text triplets. So I believe that all of the pre-training is done with this format of video, audio, text triplets. So it's like the same amount of data for all modalities. So there's like this 136 million video, text, and audio triplets.
VATT, VAT. The link to the paper is in the blog actually. So
yeah.
Read in more detail. So let's move to reinforcement learning. I think Sergey, you picked this paper because it was the paper with the highest weight in our ranking for all of NeurIPS in terms of age index, right?
Okay, the authors are pretty well known.
And Sergey Levine together, they bumped the chart.
But the second reason is also because this is about it talks a lot about compression, right? And I said that was my my hobby for a little bit.
Your
so
hobby.
so I had to include it. I still think it's really interesting, this perspective on the reinforcement learning. What do you think, Jakub?
I have to admit I only skimmed this paper because I don't know all that much about reinforcement learning. But there's actually a website for this paper, and on the website, Ben Eisenbach does a 3-minute video explaining the paper. And the funny thing is, it's about compression in reinforcement learning. The video is very compressed. He talks really fast, beyond natural. So it's like a 3-minute video. I think he compressed 10-minute explanation into 3 minutes, and it goes really fast. But anyway, so the gist of the idea is that when you have this kind of reinforcement learning agent, and to the sort of the reward function gets modified so that kind of the number of bits that you need to explore the next perceptual state is subtracted from the reward function, then you get an agent which kind of learns to minimize the number of bits that it needs to consume in exploring the whole space. And that leads to actually very good compression, so very efficient agent, but it also leads to agents which are kind of boring.
Because they play too safe, right?
So the example that they give is this agent with standard reinforcement learning that learns how to drive a car in a simulator, and they will be overtaking the other cars all the time because it's just slightly faster and get more reward. But this compression-based agent, it actually kind of boringly stays behind the other car because that reduces the number of bits of information that it needs to explore this space. So I agree that that's very interesting. The example is a good one. And so Ben Eisenbach in the video says the implementation is embarrassingly simple. And actually the code is on GitHub, and the whole code for the whole paper is just a little bit over 1,000 lines of Python code. So you can basically go read it over the weekend.
So also pretty compressed, so all
Yes.
meta consistent.
Compression rules.
All right, so I really want, we don't have a lot of time, and I really want to get to this. Oh, we have another.
This is just, I wanted to mention, this is another paper from the same trio of authors, which might even have more impact over the long term. I think this sort of like not modeling the reward function, but providing examples of good, like good outcomes. That's super interesting idea, but don't want to dwell on it.
Yeah, so this is the one that I want to talk about, which is a new evaluation benchmark for few-shot settings. So we've seen in the last year and a half, well, pretty much since GPT-3 was released, that a lot of these big models kind of are benchmarked in this few-shot or zero-shot regime. I think it's really interesting, but there was not really standardized way of doing that. And I think that this paper tries to standardize that. And I think that's really interesting. And if people pick it up, it might be really impactful and relevant. So Marzi, what do you think about this?
Yeah, I think that's I think that's a very good description, like trying to standardize and unify how we do few-shot learning in NLP. And this paper actually covers different parts about it. So they try to come up with some principles, like different points that we have to have some sort of like standard and common ground. And in order to be able to compare different models, so just saying one model works well on few-shot learning, that doesn't really tell us much. So they look at what would be a good set of requirements and best practices for evaluation of few-shot learning and comparison of different models. So they test across 4 different few-shot transfer settings, which I think is also like interesting. So a lot of times we say transfer learning, but just because how the field has grown in the past couple of years, that this can also have different meanings, right? So there are different transferring that can happen. So it's like the class transfer or domain transfer, task transfer, pre-training transfer, and you can also go beyond like language transfer, things like that. So like having the common language for that. And then they also have these like sets of how the diversity of these types, transfer types should look like, about the unbalanced training set and how important that is to actually have training sets in your benchmarks that are unbalanced to basically mimic what's going on in real world. They also, one thing that I find interesting is have in their principle is the textual labels. So they say that going beyond numeral labels to have textual labels, so that when you do zero-shot learning, you can also use the text of the like description of classes or name of classes to help your learning, and like different basically principles that they come up with. They do also provide a method called UniFew, that they try to basically close the gap between the pre-training and the fine-tuning stage and on these few-shot learnings, and they evaluate on all of these data sets and metrics that they introduce.
Is this paper a little bit similar to the BEAR paper or BEAR benchmark in neural search, like in the sense of evaluation?
I think it's a bit more abstract than that. So BEAR was focused on one task on retrieval, and they only look at, well, they do look at like evaluation in each of the data sets, and also like one zero-shot learning in one other data set. But for this particular benchmark, the principles are the keys. Like for instance, the data sets, how you use that, and also then they also have a section about the evaluation, which they introduced to like pre-training only or meta-trained only. So usually in benchmarks like BEAR, I think it doesn't matter. So as long as you are consistent with what you are doing, yeah, that's fine. But in this scenario, you have to be consistent, or you have to at least be transparent about how you are doing your evaluations, so that different models are comparable.
Yeah. Well, we saw a lot of benchmarks coming up, like DynaBench and Superglue and all that. And it just moves on, evolves all the time. So we'll see how popular this gets.
Yeah, but I feel like that what you said, like the transparency is really important, because a lot of how results are reported for these huge language models, there are a lot of these tiny details, right, are sometimes not that clear. So doing apples to apples. Sorry?
Few but not so few shot learning.
Yeah, exactly.
Almost zero shot learning.
So yeah, so like doing apples to apples comparisons is a really important thing, and especially when the incentives are kind of very strong to make the author's model kind of outperform.
Yeah, so I think that's like two I think main conclusion for me for this paper is that, one, being able to have a standard way of comparing two different models, and two, really defining what few-shot learning actually wants to capture, like being able to close to real-world examples as much as possible, and being able to also work for models that we don't know, like, or languages or data points that we don't have data for. So they try to actually define it in a way so that you don't take advantage of some developments that you can still fine tune on, or things like that, like a real scenario few-shot learning.
Yeah, I think that's super, and so I'm really looking forward to see if they really pick it up, right? Because that's the important thing.
We don't have to spend a lot of time on this one, right? But you picked this one. So why did you pick this paper?
Yeah, it was just kind of cool. I don't know, like the idea was just kind of so cool, and it's a pretty light kind of read, and like the whole concept is not complex or anything. It's just kind of this gameplay between two models, right? And one needs to learn a way to sketch images, and the other one needs to be able to detect, like, to learn like what the drawing is, like what the original picture is from the drawing.
So and with some Pictionary for AI.
Yeah, exactly, Pictionary, and it's kind of cool. And I don't know, like they explain how they regularize these neural networks inspired in how the visual cortex in the brain works, and all of that. It's just kind of really fun, the results. So
all work and no play makes Jack a dull boy. So you have to have some fun to get good.
Yeah, right? Exactly. Yeah, absolutely. And this last one is also it's also a bit of a weird pick, right? Because the paper focuses a lot on the theoretical aspect of things, but I think that the gist of it is really interesting and practically relevant food for thought for everyone who's doing machine learning work, right? So Jakub, maybe you can give the gist of it.
I will do it very quickly. So basically the question that they're trying to answer in this paper, Fixes That Fail, is if you have a huge system that's made up of many different machine learning models, some of which might be like third-party models or legacy models that you cannot retrain, and or like gradient boosted decision trees which are not differentiable, so you cannot retrain end-to-end. If you improve one of these models, these component models, you like raise its accuracy or lower its loss, can improving this one model make the whole system worse? And the answer is yes. The answer is a big yes. And actually, they say in this quote here, even if all the downstream models are retrained after updating the upstream model. So it's a really, this is the hairy mess of MLOps, right? And you realize why it's important when you realize that actually what they're talking about is a self-driving car scenario. It's kind of in this cluster of papers about robustness of self-driving car systems, and you realize that one of the models is like a pedestrian detection system, and the other is like the lane changing system, and you improve both of them, but the car like drives up, So. And I think if you're interested in MLOps and on this kind of system interaction thing, this is the classic. Scully, NeurIPS 2015, Hidden Technical Debt in Machine Learning Systems. They basically say the same thing. Changing anything changes everything. So that's the moral of the story.
Yeah, absolutely. Cool. So I think we have a few other remarks on the workshops, right, from NeurIPS.
Yeah. So is there any like any tips or tricks or like papers that you guys in the audience discovered that we should talk about, or do you have a particular topic that you're doing research on and you would like us to do kind of mini research on what's in NeurIPS for you, drop your
yeah, I just left the question in the chat, so feel free to add that. We can look it up. We can just switch in the meanwhile. I think we have some.
If you have topics that you want us to research, well, just let us know in the chat, and we'll move on to the workshops. So after the conference, after the 2,300 papers, there's another 2 days, mostly Monday and Tuesday next. So 1 week from now, with 60 workshops. So that's like 60 mini conferences with like many dozens, or even some cases hundreds of papers. Yeah, that's overwhelming. But here's a few of my favorites. So there's a one on efficient natural language processing. I'm an NLP guy, so definitely gonna attend that one. There's a data-centric from AI from Andrew Ng, and I'm kind of into self-driving cars lately. So there's a full-day workshop on Monday on like with about 2 dozen or 3 dozen papers on self-driving cars. So I'm actually going to be kind of blogging and live tweeting about that. Tackling climate change with machine learning. And one which I think is really very fascinating, do I have it here? Is the AI for science. So it's like scientific discovery through AI. And that's like more than 100 papers ranging from physics to cosmology, chemistry, drug discovery. Great workshop. So definitely, if you're bored on Monday in a week, check out AI for Science as well. So what else?
Yeah, good recommendations. I just wanted to mention earlier we talked about self-supervision and how hard it is. I think there are 2 workshops like separately on self-supervised.
Oh, 2 workshops. They didn't know about each other. Well, there's this one. I have one of them here.
Yeah, there's some differences.
Yeah. And if you're into like more the sort of ethical and political side of AI and its impact, there's also a lot to be discovered in the workshops.
Mm-hmm.
So
yeah, a couple of quick
wrapping up. There's always kind of the hidden gems and finds. I found 2 papers by students from Jürgen Schmidhuber. Of course, he's kind of had a big impact in the history, and it's kind of feeling a bit frustrated about not being recognized. So here is actually has a paper on meta learning for improving the backpropagation algorithm in a biologically plausible way. I think it's actually fascinating, and he's trying to reclaim transformers as being his idea of recurrent fast weight programs. So, but definitely interesting to check it out. A lot of good work coming out of Europe as well. Yes. And last but not least, how do you get your paper in NeurIPS next year in 2022? So there's this paper. It's a really accepted paper, and it says you have to review your own paper, and then you get in.
So before we close up, there's a question from Srishti saying if we can recommend any NLP specific conferences to look for. Maybe Marcy, what is your favorite NLP conference, for instance?
Yeah, I would say like the big 3s are the ACL, EMNLP, and then depending on the year, NACL or EACL. So because they're like by annual, also depending on the location. But like the ACL family of conferences is a good start. But I would also say that don't ignore these conferences that may seem like really theoretical machine learning conferences like NeurIPS, iClear, ICML. There are often a lot of good NLP papers there as well.
Yeah, even HKI, Triple AI. But EMNLP would also be my favorite for NLP. That was just in November.
Mm-hmm. Yeah, I just shared it in the chat, the specific names.
All right.
That's all right. It. So yeah.
Thanks.
Yeah, on the clock. Yeah. So thank you very much for everyone. This was fun, and we'll see you next time in January.
Yeah,
Jakob, do you have any closing words?
We hope we can do something something with champagne and glasses, but who knows?
You also wanted to mention, Jakob, the Search Engines Amsterdam happening in a couple of weeks.
Oh yeah, that's December 16th. There's a book launch from about neural search from a couple people we know very well, and we're sponsoring it. So Search Engines Amsterdam, December 16th, we're going to be there. Check it out.
Great. Marzi, any closing words?
No, that's it. I look forward to the next edition to see what comes in over the holidays. But and also like next week, NeurIPS.
Yeah, we're going to be live tweeting, and so follow our Twitter account, Zeta Vector, and we're going to be reporting on like whatever we stumble into this, you know, a huge pool. I think there are more than 15,000 people registered now for NeurIPS. 15,000.
15,000, yeah.
It's going to be more by next week because some people are late.
Yeah, quite crazy. All right, so yeah, enjoy your weekend, and thank you. Bye-bye.
Bye.